Okay, so let's do number 1 in 5.5, for which we have y double prime plus 3y prime plus 2y equals 7 cosine x minus sine x. Okay, so firsty things first, find r's.
That was no problem.
Okay, so look at this thing and think to yourself, all right, the associated homogeneous equation looks like yh double prime plus 3yh prime plus 2yh is 0. And then you look at that and you think to yourself, okay, so r squared plus 3r plus 2 is 0. And so that factors into r plus 1 times r plus 2. Okay, so r is either -1 or r is -2. And so your yeah.
On a test, do we need to do all this stuff? This extra steps down here? Do we skip it?
Skip it for what?
Like once we get the factor, do we have to just like write out our r's and all that?
It depends on what you're
straight
asking.
into the homogeneous equation.
Right. So I didn't ask a question really here, right? So I guess the question was find a particular solution. For the particular solution, I don't actually care what the homogeneous solution is, right? So yeah, you're right. I could really stop at here, right? And just think to myself, okay, so where did the cosine x and sine x, where did those guys come from? Yeah, those were given to you, but what's the r that would give you cosine and sine? Yeah, that would be an I, right? Maybe plus or minus I, right? Why not a real part?
Because there's no exponential attached to it.
Yeah, there's no exponentials attached. Why the I? Because there's a sine and a cosine with a 1x inside. You guys with me on that? Okay, so those r's don't match these r's, and that means that I should guess what for a particular solution? Perfect. I would guess yp is a cosine x plus b sine x.
And then if they did match, you just add enough x's until they didn't match.
Yeah, so if these were plus or minus I, right, I'd be slapping an x on there. If these were both a real value, and this thing was an e to that real value, then I'd be adding an x squared.
Does minus I not have minus 1 as coefficient? Is there just no 1 there? It's just I? Because there's r minus 1 minus I. Would that,
Oh, this minus 1 and minus I, yeah, those are different.
you have to write a 1.
Yeah, minus 1 is a real thing, I is an imaginary thing. Those definitely are different spots.
Yeah, but like if you have negative x, you sort of just assume like oh, there's a 1 before that. But
Yeah.
1 and I is the same thing.
Yeah, ones and I's are different.
Fine.
Okay, so this is my guess. So then what do I do with my guess?
Differentiate.
Differentiate it twice.
Differentiate a couple of times. So yp prime is going to be a, wait, cosine's derivative is
Minus a.
sine x plus b cosine x. And then yp double prime should be
Negative a cosine x.
negative a cosine x plus
Minus.
b sine x. Okay, and then what do you do with those?
Plug them in.
Plug them into your original. So I think I got minus a cosine x minus b sine x. So this part here is yp double prime.
Sure.
That guy. Then there should be a plus 3 times
YB prime.
yeah. So this guy should be yp prime, which is minus a sine x plus b cosine x. Right? Okay, then what else?
Plus 2 times YP.
So we need plus 2, and then this piece should be a y particular, which would be a cosine x plus b sine x. And this is all supposed to equal
That jazz.
the non-homogeneous thing, so 7 cosine x minus sine x. Yeah, so go through collect like terms. So looking for cosines. Actually, let me do good math studenting up here. So good math studenting would be multiply this out first, then collect like terms.
Yeah.
So that I don't drop any constants. Basically, I'm worried that if I do this a little fast, I'll dork the constants, then it won't work. So I think I got minus a cosine x minus b sine x minus 3a sine x plus 3b cosine x plus 2a cosine x plus 2b sine x should be 7 cosine x minus sine x. Okie dokes.
Then you combine the terms.
Then you get out your colored markers, right? And you go, all right, cosine's there. Where else? Cosine's there, cosine's there, and cosine's over there. So the red stuff all told gives you minus a plus 3b
Plus 2a.
plus 2a equals 7. Right, so I'm forcing the number of signs on the left side, or the number of what? Cosines on the left side to be the same as the number of the cosines on the right side. Then you go through with another colored marker and find the signs. So I got sines, 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 sines. And so that equation should read
Minus b minus 3a.
minus b minus 3a plus 3b
2b.
equals
Plus 2b.
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 Dorking up constants.
Dork, see, I told you. This is why I'm not actually good at these.
Equals -1.
Equals -1.
I almost dorked up that part.
It happens. Okay, so the moral of this story with these, right? Slow, careful. Slow and careful will get you there. And then what?
Oh,
The, the bottom one by -3. Multiply that. After you simplify it.
Okay, so simplify a little bit. So it reads like the top one there is 3b plus a is 7, and the bottom one reads like minus 3a. Oh, this is stupid. How about we put the b's first since I decided to do that?
b minus
So I think I have b minus 3a equals -1. And then solve this somehow. I don't care how. So you suggest?
I just multiplied the bottom one by -3.
Why not just solve bottom one for B and then plug it in?
Sure. Either
Right
way.
away.
Don't care what. So I'm going to do -3 because that was first suggested, but whatever. And then add, and you get
10a equals 10.
10a equals 10. Okay, that tells me a is 1. And then b is 2, I think, from that one.
Yep.
Go to your favorite spot and find b, right? And then what do you do with that information?
You put it back into your particulars.
Take that all the way back over here. So grab that, bring it back here, figure out that then your yp is cosine x plus 2 sine. Check done. That's your particular solution.
And it only took 3/4 of the board.
And it only took 3/4 of the board, and I only crammed part of it in there. I really kind of crammed my elimination step in there. If I was doing good board work, I would have taken that somewhere else. Yeah?
So if, when we were playing around with that, plus or minus I, and then our solutions down at the bottom,
Yep.
basically since they were the same, we just guessed. Yeah? Or they weren't the same, I mean.
Yeah, since they weren't the same, I guessed something that looked like my non-homogeneous part.
Yeah, and
Right.
we have techniques for if they were, but
Yep.
otherwise you're just kind of going for it.
Yeah, and really this is the spirit of method of undetermined coefficients. Like, if the right-hand side looks like a kind of thing you could get out of something like the left-hand side, if you put it, like, if you put something that looked a little bit like the right-hand side into the left-hand side, if it would still be of the same form, then you should guess something like that.
Trig functions, e to the x. that kind of stuff.
Yeah, with the exception of like, if you have an arctangent over here, right?
Yeah.
If you differentiate an arctangent, you're going to get some rational functions, right? You're going to have to cancel those out with something, but you don't have any rational functions. So then maybe you'd like guess some rational functions, but then when you put rational functions in, you expect to get, like it just becomes a feedback loop, right? And that might not be good. So if it's not something that's going to stay basically of the form it is, and that would be something like an exponential function, a polynomial, or sine or cosine, then you probably are okay guessing those things. If it's something else, method of undetermined coefficients doesn't give you a good bet. That make sense?
Mm-hmm.
There are other things. We could try the modern version of variation of or the kind of new age version of variation of parameters, which I'm going to show you today. But it's a little bit like it's overkill when I see sines and cosines because I'm like, dude, sines and cosines begat sines and cosines, so I could just guess sines and cosines and be done with it. You guys cool with that? If I do variation of parameters, there's a whole giant rigmarole that I have to go through.
Yeah, the several rabbit holes that we kind of talked about last time.
Yeah, it's a little bit rabbit hole-y. Cool. Questions on this? Where were you stuck?
Well, when I was looking at the examples, I was kind of trying to follow how they were doing this. It was like a of 0, a1 of x, instead of just a. It's like every spot there would be an a, they had one of those. Every spot there was a b, there was one of those. So I ended up with like a of 0s, a of 1s, a1 of x's, b of 0. You know, it was just so many, I wasn't quite sure how to break it down.
Yeah, so what they're doing is they're looking right here at this guy and this guy, right? And that's a -1. And they're thinking to themselves, if there was a polynomial there, I should be putting a polynomial there. These are really dumb polynomials, right? But if this was an x, then my form here would be ax plus b cosine x plus cx plus d sine x. Because I'd have to guess a first order polynomial in there. I'm getting away with something because these guys here are 0-degree polynomials. And so I'm guessing over here 0-degree polynomials. Does that kind of make sense? So that's where they're doing that A0 thing. Because they're preparing for worst cases.
I never changed that.
So that's pretty much
We
my
did it
question
right
on
again over
12.
there,
Is
remember?
it's similar to that, but it's on the other side, on the right side of the equation, it's 8x squared cosine x
Yep.
minus 4x sin x.
That's
So
just the
when
particular
I have
part.
my
I just wrote up a whole
ax
section.
plus or ax squared plus bx plus c,
This is
right,
general.
times my cosine.
Yeah.
Do I also have to multiply that particular, like, to the second degree polynomial on the sine, even though it's a first degree
So I
polynomial on the
can't do
sine?
basic.
Yeah. Yeah, you need it on both
So
pieces.
second degree both of them.
Second degree both pieces. So that, for those of you who didn't quite hear all of that question, that would be, what if instead of this stuff here, what if I had something like x squared cosine x minus sine x?
Yeah,
Right,
well,
like-
it's sine x times like x or something. Yeah.
So I have a second degree polynomial here and a first degree
Yeah,
polynomial
so that's why I was
there.
getting thrown off. I was like, do I second degree both of them? 'Cause
Yeah,
then it
you need to
seems like
second degree both of them because when you differentiate, they kind of switch spots, right?
Oh, yeah.
And so you'd like to account for that behavior of, well, they might switch spots later on.
So do you get a lot of zero values then for your, like,
Yeah, you'll probably get a lot of things that zero out, but that's only because the book's being nice to you. If you, at random, pick a differential equation, and then at random pick a second degree and a first degree polynomial here, it'll be messy. You'll have to find all three coefficients for both things, and probably they won't all be zero, or at least a bunch of them won't be zero. But when the book writes a problem, they go a little bit out of their way to make the numbers nice. And this guy is especially nice about doing